Today we're going to keep looking at whether functions are linear or nonlinear. The difference is, yesterday I was letting y'all use Desmos. We're going to do it without Desmos today. So no calculators. All right, to start with the functions, or with the equations. If we have exponents, exponents automatically will make a function nonlinear. Okay, it's going to make the function curve in some way. So if you see an exponent on an x, that's going to make it nonlinear. If you see an exponent on a y, that's going to make it nonlinear. Both of these happen to have an exponent of 2. It doesn't have to be 2. It could be any number, positive or negative, okay? If you see a square root symbol, square root symbols count as exponents, okay? One thing I forgot that I probably should have added up here, if the variable is an exponent, that will also make it nonlinear, okay? So basically, if you see an exponent, in most cases, that's going to make it nonlinear right away. Everybody good with that? Exponents, nonlinear. Variables multiplied by variables. That's going to make an equation nonlinear as well. So it could be x times y or y times x. Sometimes what you see, though, is with parentheses. When we have parentheses, we do the distributive property, right? When distribute, what type of math do we do? Multiply, right? So we would do x times x right there, and x times x, that's going to equal x squared, which is the exponent, that's why those are nonlinear, okay? But x times y or y times x, order doesn't matter. Variable times variable makes it nonlinear, okay? Then the other thing that really shows up is variables as a denominator or in the denominator. So that means you could have just an x or just a variable in the denominator, or you could have the variable doing some sort of math operation in the denominator. If a variable's in the denominator, it's going to make it nonlinear. We could also have the y value as the denominator, and that would make it nonlinear too. Okay? Everybody good on those? All right, so this is one we looked at yesterday. So who can tell me then, out of those, which one is linear? Hunter? B is correct. So basically when you're looking for which one is linear, you're pretty much eliminating the nonlinear ones is probably the easiest way. So what's wrong with A? Why is A nonlinear? We have x as a denominator. That makes it nonlinear, okay? We said B was the correct answer, so what about C? It has that there, so that makes it nonlinear. D? Same idea. As I said before, it doesn't matter what number the exponent is. Any exponent on a variable or a variable as an exponent will make that nonlinear. All right? Everybody good on those? Those are relatively easy, and once you get the hang of them, you get them pretty quick. It's just something you kind of got to remember. Where it gets a little trickier is if we have tables, or if we have a bunch of ordered pairs and we have to tell which one's linear or nonlinear. All right, with Desmos, you put it into the table and you just kind of got them graphed, and that showed you. So one option would be you could take graph paper or the back of y'all's whiteboards, and you could graph all these points. That's probably not the easiest way. All right, so watch this. Our x values. How much are they going up? 2? Right there? Right there and there. All right. They're going by the same amount every time. All right, my y values, they're going down. Down by how many? 3. Since it's going down, I'm going to put -3. That's not super important for linear or nonlinear, but for what we're doing next, that will. It's what? 3 every time. All right, so look. All of these, well, that wasn't supposed to move, but we get the idea. All of these here are the same. We got 2 for the x value, a -3 for the y value, right? If everything's matching, it means it's increasing or decreasing by the same amount. It's going to be linear, okay? Make sense? What these are is this is the rate of change you would have, okay? So, I mean, I kept the x's the same, so we're still at 2 on the x's. How many are we going down right there? Down 6. How many are we going down right there? 5. So right away, is this one linear? No. I mean, if we kept going, that's down 4, that's down 3. It follows a pattern, but we don't want a pattern. We need it to be the same every time. Everybody kind of follow on that? Now, for today, we won't get any like that, but I'm going to pretend this one's not here, okay? So from here to here, that's 2. Well, you know what? We'll go back to the other one. We're going to pretend this one's not here, okay? So from here to here is a change of 2. There to there is -3. There's 4. There's -6. Are those the same then? Yeah. Okay. It's going to work kind of like fractions. All right. This is the rate that the graph's changing. Our rate of change is like a ratio or a proportion kind of thing. And if I put -3 over 2, and I've got -6 over 4, what number goes into both 6 and 4? 2. So if I divide by 2, 6 divided by 2, that's going to give me that -3. 4 divided by 2 is going to give me that 2, okay? We won't worry about those too much for right now, but just wanted to show you that those do happen sometimes, okay? All right, y'all try that one. We need to find if that is linear or nonlinear. Marcos? Nonlinear. If you look, every time our x values, they're going up 1. How much the y value is going up there? 2. What about right here? 3. And right there would be 4. Those aren't matching, are they? All right. Everybody see what I mean? See how this works? All right, let's try another one. Nick, what you got? Nonlinear is correct. Same idea. We got going up 1 each time. We got 3, 5, 7. So there is a pattern there. It's just not what we're looking for, okay? We're looking for it to go up or change by the same amount each time, that same rate. I got some negative numbers, so maybe a little trickier, but. Corey? linear. So we got 4s increasing by 4 on the x values. For the y values, we're going down 3 each time. So that means we got matches, okay? Everybody good on that? All right, let's do one more. Carlea? Nonlinear? No. Jenny? Linear. All right, so our x's, they are going up 3 every time. What's happened to our y values? Decreasing by 2. So we got -2 here, -2 here, -2 here. Okay? Is that super difficult? No. Again, no, something more to remember, something more we got to be able to check out correctly, okay?